In this video, we're going to learn how to use the array class in C++. The array class is another way of working with arrays in C++, rather than using C-style arrays. So C-style arrays look like this. We could declare an array of 5 integers like this, and we could initialize them with 1, 2, 3, 4, 5 here. We could access the element at index 1 with array at index 1 here, and we could print it out. We could also set it. We could say array1 at index 1 is equal to 10, and we could output it again just so we can see that it changed. And if we save this and run it, we'll get 2 and 10 as output. And that would be a C-style array. We call this type of array a C-style array because they come from the language C, where C++ actually originated from. To use the array class, we'll first have to include the array library. And then to declare an object, we'll say array int 5 array2 is equal to 1, 2, 3, 4, 5. And so we're able to initialize the array the exact same way as a C-style array. We can access the array elements in the same way too. I'll actually copy and paste this code. And by just changing the name of the array, it'll work. We'll just say array2, array2, and array2. And if we save and run this, we'll get the exact same result as before, with 2 and 10 as the array element values. So the array class is really a class template that allows us to work with arrays of different types and sizes. In this case, we're creating an array of ints of size 5. Internally, the data in the array object is represented using a C-style array, but the class acts as a wrapper for this data. And we're provided with a set of member functions to help us work with this data that we'll go over in this video. We don't get these member functions with a C-style array. And so the capabilities of the member functions are really a key benefit to using the array class instead of C-style arrays. So let's go over these member functions. The first thing we'll do is make a new array object. We'll say array, open bracket, int comma 5, array1 is equal to, and we'll have 9, 8, 7, 6, and 5 as the array elements. Now this open bracket, close bracket operator here, we call this the subscripting operator or the array index operator. That is overloaded for objects of this type, so we can use it. So we can output here the array element at index 1 is equal to, we can output the element itself, followed by an inline, and this will work. We can also use the @member function. So we could say cout, output the array element at index 2 is equal to, and here we'll call the member function. We'll say array1 at 2, and we'll output the element at index 2 in this array here. So we'll save this, run it, and we should get 8 and 7, and we do. Now there are also member functions to find the first and last element in the array, and they're called front and back. So we could say cout array1 dot front is equal to, and we'll output array1, and we'll call the front member function. That's going to give us the first element in the array. We could also output array1 dot back is equal to, and we'll output array1 dot back, and we'll call the back member function here. And that will give us the last element in the array. And if we save and run this, we should get 9 and 5 for the front and back, and we do. Now there's also a size and a max size member function, and those will give us the size of the array. So we could say cout array1 dot size is equal to, and we could call the size member function, and this should give us back 5. We can also call a member function called max size. So max underscore size is equal to, and we'll say array1 dot max underscore size, and then we'll also output an inline here as well. Now max size would be more relevant for other classes that are related to this array class. So this array class is what's called a sequence container class. And there's several other sequence container classes. And for those classes, the max size member function is more relevant. For the array class, it actually just returns the same thing as the size member function. So if we save our program and run it, for both size and max size, we get back 5 because our array stores 5 elements. We could use the size member function to help us output the array values. So for example, we could say for int I is equal to 0, I is less than array1 dot size, and then I++. And then here we could output the array element at the index I is equal to, and then we could output the array element itself by using the index operator. And if we save and run this, we should get a nice output of the array elements here, and we do. Now we could also use the fill member function to fill an array with a particular value. So we could say array int 5 array2, and we'll declare a second array called array2. We could say array2.fill, and we could pass in a value here, and the array will be filled with that value. So we'll try 10. Now let's output this array, and we'll actually just copy and paste this code here. So we'll copy this, paste it here, and we'll change this to array2 and array2. And then one more down here, we'll change this to array2 as well. And if we save and run this, we'll find that array2 is filled with the value 10. And that's the fill member function. Now using this size member function like this in the loop condition might be a bit concerning, because this size member function, we might think, is doing some work to compute or return the size each time. Maybe there's an overhead to calling this function to actually return the size each time so that it's used here. We might do something like this instead. So set a variable length equal to array2.size, and then put length here instead, thinking that this will save some work. So that way the size is only found once, and then we just use the variable here each time. This is actually completely unnecessary though. We can actually just switch it back to how it was before. So the compiler will actually replace this here with the actual size of the array, in this case 5. There will be no work done here. It will actually be replaced with a constant value 5. And our program, as it's running, will just use that constant value 5. It won't do any extra work to find the size as it's running. So that's kind of a cool feature as well. Now one thing we can do is actually swap array values. So we could say array1.swap array2. And the swap member function will actually swap the values of array1 and array2. So let's print out array1 and array2 again to verify that a swap took place. But this time we'll use a range-based for loop. So we'll say output array1 colon, and then we'll use a range-based for loop. So we can say int element colon array1, and we'll output each element in the array followed by a space. And then when that's all done, we'll output a new line. So this here is called a ranged base for loop. And a ranged base for loop we can also use with the array class. And what's going to happen is that each time this for loop body runs, the next element in the array is going to be assigned to this element variable here. And then we can output that element here. We could also output the array2 elements in the same way. So we'll just copy and paste this, put it down here, and this time we'll output array2, and then here we'll have array2. And if we save this and run it, we're going to find that array1 now contains all the 10 values, and array2 now contains 98765. Now there is also an empty member function, and the empty member function will return true if the array has a size of 0 and false otherwise. Similar to the max size member function, the empty member function is more useful in some of the related sequence container classes such as vector, but we can use it with array class objects as well. So for example, we could say if array1.empty is true, then output array1 is empty, followed by an inline. Otherwise, we'll output array1 is not empty. And we know that array1 has size 5, so array1 should not be empty. Let's test an array that is empty. We'll make an array with a size of 0, and we'll call it array3. We can test this one as well. We'll say if array3.empty is true, then output here array3 is empty, followed by an inline. Otherwise, output array3 is not empty. And array3 actually is empty, so in this case, we do expect it to output array3 is empty. We'll save this and run it, and we get array1 is not empty, and array3 is empty. We also get these compiler warnings here, where it says code will never be executed in both cases. The reason why we get that is the compiler can already tell, based on the size of the array, which is determined at compile time, that these branches of code will never run, because the compiler knows that array1 is not empty. The compiler knows that array3 is empty. So because the compiler is already aware of this, it gives us a warning. Now we can also access the internal array inside of the array object. So we said that inside of our array objects, the data is actually stored using a C-style array. And the class acts as a wrapper with these member functions that are going to help us work with that array. We can access that array directly by using the data member function. So the data member function will actually return a pointer to that C-style array. So for example, we could say here, int star pointer is equal to the return value of this member function call. And what we're going to do is store that pointer, store that memory address for the C-style array into this pointer variable here. Now we can access that array using either array notation or pointer notation. So we could say star pointer plus 2 is equal to 20, or we could say pointer at index 3 is equal to 30. And so given this pointer to the actual C-style array inside of the array object, we're able to use pointer notation here to modify the element at index 2, or array notation to modify the element at index 3. Let's actually output array1 so that we can see what it looks like after we've made these changes here. We'll copy this and we'll paste it down here. We'll save and run our program. So array1 had been set to all 10 values. But if we look at the array now, the element at index 2 has been set to 20, and the element at index 3 has been set to 30. So we were able to use this pointer to the C-style array inside of this array1 object here to actually manipulate the values of that array. Now we keep repeating the code to print out the array. It is possible to call a function and give an array object as an argument. So for example, we could make a function here called print array, and the function could have a parameter that is an array object that stores ints with a size of 5, and we'll call it ARR. And then in here, we could have our usual code to output the array elements. So we'll output array. We use a range-based for loop here to output each element in the array, separated by a space. And then we'll also output a new line here as well. So we'll save this and we'll try this function out. So down here, we'll actually call print array, and we'll pass it array1 as an argument. And if we save this and run it, we can now print out the array, but this time we're using a function instead, which is going to reduce code duplication. So the array class is defined inside the standard template library in C++, which provides a collection of useful templates for data structures and algorithms. The array class is a container class within this library, and the container classes are class templates that store and organize data. More specifically, the array class is a sequence container that stores data in sequence. The sequence container objects are capable of returning iterator objects that allow us to iterate over the elements of the container. Let's go over an example of using iterators to loop through the array elements. So let's print out the array elements. We'll say cout array, and this time in brackets we'll say iterator print, just to specify that we're using the iterator objects this time to print out the array elements. Then we'll make a loop. We'll say for array, open bracket, int 5, close bracket, colon, iterator, it. So this here is an iterator variable, and we're going to assign to it array1.begin. So the begin member function is going to return an iterator that points to the first element in the array. And the iterator objects work kind of like pointers. They have some similarities. We'll put a semicolon here, and then we'll have it doesn't equal array1.end as our loop condition. So end is going to return the iterator that points just past the last element in the array. Then we're going to increment the it iterator with each iteration of the loop, so that eventually the it iterator will reach the end of the array. Then in the loop body, we'll output the array elements. We'll say cout, and we're going to dereference the iterator. We're going to say star it followed by a blank space. So dereferencing the iterator will give us the value in the array that the iterator is currently pointing to. After that, we'll output an inline. We can save this and run it. And now we're printing out the array again, but this time we're using iterator objects to do it. Now this type here is pretty complicated. There's a simpler way we could do this. We'll copy this and then paste it here. And instead of this type here, I'm just going to put auto here. So by using this auto keyword here, the compiler is going to figure out the type of this variable based on the way that we're initializing it. So if we were to then change the length of the array later, let's say, we could actually just leave this code the same and it would still work. So we can save this and run it. We'll get the array printed out with the exact same values as before. Now one more thing we can do is print out the array in reverse. So here if we say rbegin and rn, the iterators are going to work in reverse. So we can save this and run it. And now we get the array printed out in reverse with 10, 30, 20, 10, 10 instead of 10, 10, 20, 30, 10. We could also say rbegin and pass in array1 as an argument and rend and pass in array1 as an argument. And this will actually work as well. And we could do the same thing with begin and end in our loop above. And that would work as well, because begin, end, rbegin, and rend, those are actually global functions. Finally, one more difference between C-style arrays and the array class that I should mention is the ability for the array class to do some bounds checking. So here we have an array with 5 elements. If I were to try to access the array element at index 5, the 6th element in the array, this would be out of bounds because the array only has 5 elements. With the array class, we can actually detect this if we compile in debug mode. The @member function will also throw an exception if we try to access an element that's out of bounds. And we can detect that with the try catch block. So we'll have try, and then we'll try to access the element at index 5 in the array by using the @member function. And we'll catch the error like this. We'll say catch const out of range reference or, and then here we'll output error out of range, colon, and we'll output or.what followed by an end line. And if we save this here and run it, we will get error out of range. So that's another benefit of using the array class compared to C-style arrays. With the array class, we can detect out of bounds errors. Notably, there is no difference in performance between a C-style array and the array class. So together with the member functions that are available and the ability to do bounds checking, it's often a great choice to use the array class instead of C-style arrays. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers.